P-value z-test for the mean, chapter 9. Example 1, in a sample of n equal 15 patients, the mean creatine level X bar 1.4 milligrams per deciliter. This is taken from a larger population, of all potential patients. Creatine level is normally distributed with mean mu unknown, but with known standard deviation sigma equal 0.5 milligrams per deciliter. I want to compare this to the creatine level of the general population with mean mu naught equal to 1.0 milligrams per deciliter. And so here's our hypotheses. H naught mu equal 1.0 milligrams per deciliter. Patient creatine level is the same as that of the general population versus HA mu not equal to 1.0 milligrams per deciliter. Patient creatine level is different from that of the general population. Okay, so we tested these same hypotheses before using the critical value method, but we can also compute a p-value. So in this video, we're going to compute a p-value. So okay, so the p-value is going to be 1 minus 2 times the probability that z is between absolute value of x bar minus mu naught times square root of n over sigma. So if we fill in the numbers, we get 1.4 minus 1.0 times square root of 15 over 0.5, and that's the probability that that comes out to be 3.10. So we look in 3.1 row 3.1 column 0 of the z table, and it's 0.4990 multiplied by 2, subtract from 1, and we get a p-value of 0.002. And because our p-value of 0.002 is less than our desired level of doubt, alpha equal 0.05, we reject H naught with 95% confidence and conclude that the mean creatine level of patients is different than the mean creatine level of the general population. And oftentimes researchers don't even establish alpha. They just simply report a p-value and leave it up to the reader to interpret it. And we can use this chart here to interpret the p-value. Our p-value of 0.002 is between 0.001 and 0.01, and that indicates a strong evidence that the mean creatine level of patients is different than that of the general population. So modern researchers tend to rely on p-values. In the past, not so much, because they were hard to compute without computers, or at least sometimes hard to compute. But these days, researchers often report p-values. Part B, if prior to collecting the data we are certain that the mean creatine level of patients was not less than that of the general population, we could do a right-tailed test. So here the null hypothesis is the same, but then an alternative, we have a greater than symbol. HA mu greater than 1.0 milligrams per deciliter. Patient creatine level is higher than that of the general population. Okay, so now all of our doubt is concentrated on one side, and we don't need to multiply by 2. We want 0.5 minus the probability that z is between 0 and x bar minus mu naught square root of n over sigma. And putting in the numbers, we have 1.4 minus 1.0 times square root of 15 over 0.5. And again, it comes out to be 3.10. And we look at that in the table, subtract from 0.5, we get 0.0010. And because our p-value of 0.001 is less than our desired level of doubt, we reject H naught with 95% confidence and conclude the mean creatine level of patients is more than that of the general population. And again, we can compare this to this chart here, and p-value of 0.001 indicates very strong evidence that the mean creatine level of patients is higher than that of the general population. Part C, if prior collecting the data we were certain that the mean creatine level of patients with not more than that of the general population, we can do a left-tailed test. So again, the null hypothesis is the same as it was before, but the alternative HA it now has a less than symbol. U less than 1.0 milligram per deciliter, patient creatine level is lower than that of the general population. So now we want all of our doubt to be on the left side, and our p-value is the probability that Z is less than x bar minus mu naught square root of n over sigma. And we got the probability that Z is less than 3.10. And so our table only has the probability for Z being between 0 and the number. So we want to add 0.5 to whatever we get from the table, and it's 0.9990. And because our p-value of 0.999 is more than our desired level of doubt, we fail to reject H0. Sample does not provide enough evidence to conclude that the mean creatine level of patients is less than that of the general population. And if we compare it to the chart here, our p-value is between 0.1 and 1. That indicates little or no evidence. According to the central limit theorem, these tests are valid if the population standard deviation is known and either n is at least 30 or the variable is normal. And that concludes this presentation.